For this section, we're looking at the limit of a function. So you pick an x and you pick a point. So as x approaches to some number, we want to see f of x approaches to a certain number. That's going to be the limit. And the intuitive definition of a limit, as you can see, x approaches to some number a, f of x is going to be L. So we say the limit of f of x, the limit of f of x as x approaches a equals L. So if you look at the three figure A, B, and C, x approaches to a, f of x approaches to the same L. So we have the same limit for all three figures. If you look at figure B, you can see that the function is not, the limit and f of a and the limit are not the same. So you see right here, this is f of a, but the limit is still L. For case C, you see the function is not even defined at a, but that's still okay. In three cases, limit of f of x at x approaches to a is still L. So take a look at example 1. We want to get the limit of x minus 1 over x squared minus 1 as x approaches to 1. As you can see, at 1, x is not defined. You see, if we put 1 in here, we get 0 over 0, which is undefined. But it's still okay. We can still find a limit. So you see the table. So table for x less than 1, you see f of x goes from 0.66, and then 0.52, 0.50, 0.5002, and its approaches to 0.5. So if you look at x greater than 1, so 1.5, 1.1, 1.01, so x greater than 1, but x approaches 1, f of x still approaches 0.5. So you can guess the limit of x minus 1 over x squared minus 1 as x approaches 1 is still 0.5, which is a half. Now, if you take a look at this function right here, the function g of x, so as you can see, the function g of x we have, same thing, x is not defined at 1, right here. X is not defined at 1. But if we define it and we say that at 1, at x equals 1, g of x is going to be 2, right here. But the new function g still has the same limit as x approaches 1. So the new function g, the limit still the same, still 0.5, right here. Okay, so that's still the limit. We want to guess the values of the limit of sine of x over x as x approaches 0. And then if you make a table, as a table I make right here, x is plus and minus 1, x is plus and minus 0.5. As x approaches 0, what do we have? We have 0.8, 0.9, 0.9, 0.99, and so on. So you can see that the limit is going to be 1. Okay, even though the function is not defined at 0. So the function is not defined at x equals 0. But we can still have the limit, and the limit is 1.